Assalamu alaikum everyone. My name is Sanzor and I am presenting our discrete project item level price co-movement network using CPI data along with my group members. So first of all, talking about the methodology and data processing. We apply the graph theory to understand the economic heartbeat of Pakistan. While traditional analysis looked at individual city inflations, our goal was to model how different consumer items move in Sainik across country. We analyzed 52 unique items across 17 cities over a 3-year period from 2023 to 2025 using data from Pakistan Bureau of Statistics. And then to build this network, we first had to transform raw pieces into something comparable. We created price change vectors for every item in every city. Instead of looking at price levels, we calculated the month over month differences. This removes the baseline effect, meaning we don't care if a city is generally more expensive, we only care if timing of price spikes is the same. We then use cosine similarity to measure the angle between these vectors. This metric is scale invariant, allowing us to compare a small price change in one item to large change in another, as long as their monthly pattern aligns. So the implementation, our implementation was built as a reproducible Python pipeline. It follows five strict steps, processing that to 29,608 records, generating similarity matrices for every city pair, aggregating those into graphs, computing centrality, and finally performing a temporal comparison. To ensure our network was robust against a single city noise, we implemented a double threshold system. An edge is only drawn between two items if at least 3 out of 17 cities show a similar of zero point 0.5 or higher density. So now Hamza will continue.
So a key requirement of our project was exploring different ways to weight this relationship. We implemented two skills, city count, which rewards the geographical breadth of co-movement, and average similarity, which rewards the depth or the intensity of the pattern. We also tested the sensitivity of our results. We found that as we increased our thresholds, the number of edges naturally decreased. But the relative ranking of the years remained the same. This confirms that the structures we are seeing in the graph are statistically significant and not just artifacts of our specific settings. Moving on next, our results for 2023 revealed a dense high connected network with over 320 edges and a density of 0.244. This reflects the severe systematic inflation Pakistan faced that year due to currency depreciation and energy shocks. Because these pressures hit almost every supply chain simultaneously, unrelated items began moving in sync. Our most central item was cooked dal at an average hotel. It had a degree centrality of 0.588, meaning it co-moved with over half of all the items in the basket. This is because hotel food prices bundle together the cost of any ingredients, fuel, and labor. Now, how is it continue?
Uh, Go back to the last slide, please. If you could. By the time we get to 2024 and 2025, we observe a massive, almost a fragmentation of the network. The 2024 graph, for instance, said 258 edges as inflation became more item specific. Interestingly, LPG cylinders emerged with the highest betweenness neutrality. This LPG acted as a bridge between isolated clusters of items. When fuel prices shifted, that pressure was transmitted through the network to other items that were not otherwise even connected. And by 2025, if you could go back to the last slide still, uh, by 2025, the network stabilized further, with fats, oils, and sugar adjacent items becoming the primary remaining channel for price pressure as is visible uh, through the presentation. Uh, when we get to the next topic regarding temporal and category analysis, our temporal analysis compared the network across all 3 years. We found that while 381 edges were transient, which essentially just means that they appeared during the 2023 shock. Still, go back to the last slide. I'm not done with that. Okay. 2023 shock, only 18 edges were persistent across all years. These 18 edges represent real supply chain links, such as, for instance, beef mutton and milk curd. Furthermore, our category analysis showed that items within the same category, like pulses or vegetables, consistently show higher connectivity than items in different categories, which aligns with what you would expect from standard economic expectations. Lastly, for the final topic, if we have some key insights regarding our research. Uh, Essentially, we figured out that our network analysis provides a unique window into Pakistani economy. We identified, for example, beef with bone as the most stable central item, as it appeared in top five for degree centrality across every single year, regardless of the inflation regime. Its supply chain is exposed to food, fuel, feed, and management costs, making it a reliable bellwether for cost push pressure. By moving from a deep sea network to a network, we have successfully visualized the transition from systemic crisis to market stabilization, as is also quite visible from our visualization. We would like to thank you for your time, and we hope that this has been informative.